Hello friends, and welcome back to my channel. We are at the 8th lecture now. Up until now we've done 7 lectures on this mole concept series. Now we are at the 8th lecture where we're going to do a very important topic, which is finding number of moles, as I told you in the previous lecture. So to continue that, let's start with the next topic, which is really important, finding number of moles. Because up until now I have told you what mole is, right? We've discussed what mole is. So ultimate summary from that last session was 1 mole is nothing but a very big number. How big the number is? Yes, 6.022 into 10 to the power 23. Now we're going to discuss how we can find moles for the given question. So let's start. So I'm going to do this in 3 cases. Case number 1. Suppose you have a question where they have asked you to find moles from mass given. Okay, so finding moles when mass is given. This is the first case. Finding moles when the mass is given. Suppose you have a question where they've been given you mass and they've asked you to find moles. How to do it? It's very easy. Number of moles n is nothing but the mass given in the question, called as given mass, yeah, divided by the molar mass. Simple. Divided by the molar mass. What is molar mass? I have told you that in the previous class as well. Let me repeat it. Molar mass is nothing but mass in grams. Mass of a substance in grams. That's it. Be it an atom or a molecule, that mass in grams. That is what we mean by molar mass. As simple as that. What is molar mass? It is the mass of a substance in grams. That's it. So number of moles will be given mass by molar mass. This is the very first formula that we have. Moving on to case number 2. So please take a screenshot of this one. Okay, well, let's go to the next one. Case 2. Case 2 for finding number of moles is when number of particles are given. What is at least particle? Now particle can be atoms, it can be molecule, it can be ions, whatever. If number of atoms is given, number of molecule is given, number of ions are given, then it is called as particles. So when number of particles are given, then how to find moles when the number of particles are given? When the number of particles are given, moles can be calculated by this formula. Number of moles n is nothing but given number of particles divided by the Avogadro number, which is 6.022 into 10 to the power 23. This is the formula which you can employ to solve this. That's it. I'll be giving examples of each of them, don't worry. So we've done 2 formula. Let me give you one example of both, so that we can understand how it works. So question number 1, find the number of moles n when, first question, in 10 grams of CaCO3. Suppose they have given it this question. So see, mass given. And the second part of the question is when we have 12.044 into 10 to the power 24 atoms of sodium. Okay, so let's do it. How to do both the questions here? So the solution goes like this. What is this data? It's a given mass, of course. It is given mass. And how much is that? Yes, 10 grams. What is the molar mass of CaCO3? Molar mass of CaCO3 is calcium is 40, carbon is 12, oxygen is 48. So total 40, 12, 48. The total comes out to be, yes, exactly, it's 100. So how to find moles now? Number of moles will be given mass by molar mass. What's the given mass? 10 grams. What's the molar mass? 100 grams per mole. Yeah? So mole will go up. So the answer is yes, very good, 0.1 moles. This is how we proceed with question of this kind. Simple, finished. Now, how to find the other one? How many atoms, how many moles of sodium atoms present? Moles of sodium atom will be given number of particles divided by the Avogadro number, which is 6.022 into 10 to the power 23. Cancel it out. 2. Cancel it out. 10 to the power 1. What's the answer? 20 moles. See? So this is how we can find moles when particle is given and mass given. Now, case number 3. Very interesting. So take a screenshot. I'll go to the next page. Okay, let's go to the next page now. Case number 3. Third case. When volume is given, and mind it, this is only for gas. Okay, this is only for gas. Only for gases. Don't apply it anywhere else. Okay, don't apply for anywhere else. Now, let me tell you one very important thing. 1 mole of any gas. Okay, any gas. 1 mole of any gas at STP. What is STP? Suppose the question has pressure given as 1 atm, temperature given as 0 degrees Celsius, or 273. Then the condition is said to be STP. That's what STP means. Yeah, 1 atm, 0 degrees Celsius. That's STP. So 1 mole of any gas at STP contains or has a volume of yes, of course, has a volume of 22.4 liters. You can take it like that. It's sometimes 20.7 when it is in bar, 20.4 liter when it is in ATU. It's fine. More or less 22.4 liters. So if you have 1 mole of a gas, please understand this very clearly. If you have 1 mole of any gas, then at STP, the volume is 22.4 liters. It's fixed, no matter what gas you have, whether it's hydrogen, oxygen, ammonia, methane, no matter whatever, chlorine, as tiny as helium, as big as SO3. Doesn't really matter the number of moles. If that is 1, volume will be 22.4. Please remember this. Okay, now question, how to find moles? So moles can be calculated when the question has a given volume. Okay, it must be at STP. Okay, by the molar volume. Cool. This is how we do it. Given molar volume, by molar volume. If it is not at molar volume, if it is at not at STP, if not at STP, then we need to use this P1 V1 by T1 is equals to P2 V2 by T2, and then find the volume. Keep this at STP. Let this be the question thing. Okay, put the data as per the question, put the data as per the question, as per STP, and find volume, and then put that into the number of moles formula, which is given volume by V2. But don't worry, this will be asked in 5th chapter, states of matter. In this chapter, we will only focus on this 22.4 liter thing. So this is how we do it. Most of your question which comes from this chapter will definitely be at STP, because as of now, those who are in class 11th don't know what PV equals to NRT is. So they don't expect you to know all these things. For now, just focus. If it is 1 STP, it will be 22.4 liters. Excellent. So now we are clear on this. So please take a screenshot. Okay, let's go to the next part. See, question. Find the moles of ozone when we have 11.2 milliliters of the gas. Okay, suppose the gaseous ozone is there. How many moles do we have? How to find it? See, that can be calculated by the formula. Number of moles. What is given to you? Volume. Of course, at STP. So how many moles? Number of moles will be, I don't know. The formula is given volume upon, yes, excellent, molar volume. What is molar volume? Volume of gas at STP. I might have told you this already. Yes, see, what's molar volume? This volume is called as molar volume, because what is molar mass? Mass of 1 mole of molecule. Similarly, what is molar volume? Volume of 1 mole of a substance. That's it. So that's molar volume. So molar volume at STP is of course 22.4 liters. So what's the given volume? 11.2 milliliters. What's the molar volume? 22.4 liters. So convert this into liters. 7.2 into 10 to the power minus 3 liters divided by 22.4 liters. Cancel it out. It will be 0.5 into 10 to the power minus 3 moles, or 5 into 10 to the power minus 4 moles. So this becomes the number of moles we can have for ozone. That's how we can solve this question. So whatever I said in the beginning, I have done it. We have discussed we have discussed three cases, right, of finding moles. One, when the mass is given. Two, when the number of particles are given. And three is the one when we have volume given. And now we are clear on how to find moles, and we've done one question of each just to get an idea. Now the next thing that I'm going to discuss is very, very important. Okay, next, finding number of molecules and atoms present. This is the next segment of the topic. First we did finding moles. Now we'll learn how to find molecules and atoms present. So let's begin. I'll give you a very simple formula which you can use to solve any question within less time. Number of molecules in any question is nothing but number of moles into Avogadro number. Finished. See, as simple as that. You find the number of moles multiplied with Avogadro number. Now to find number of atoms. Number of atoms will be n into, is a new term, I'm introducing a new term, atomicity into Na. That's it. N into atomicity into Na. What is atomicity? Atomicity is nothing but number of atoms present in the molecule. That's it. Meaning, like for example, what is the atomicity of water? So water atomicity will be, any guesses? 2 hydrogens, 1 oxygen, so 3. Very good. Just use this formula. It's the best shortcut you can get. It is the best shortcut that you can use to find number of atoms within fraction of seconds. I'll tell you, don't worry. That's how we can find the molecules and atoms. Please take a screenshot. Okay, let's go to the next part. Next, finding mass. How to find mass? How to find mass when we have moles given? Finding mass. So mass can be calculated by the formula. Mass is nothing but number of moles into molar mass. How exactly got this formula? See, it's very easy. Yeah, it's very easy. Number of moles is number of moles into molar, n number of moles into molar mass. Because number of moles is nothing but mass by molar mass. Mass by molar mass. What is the mass then? Mass would be, yes, cross multiply. See, mass will be number of moles into molar mass. And that's how we can solve this. Done. Very important formula though. That's how we can find mass. So first find the moles multiplied with molar mass. A very, very important formula for finding mass. One more thing you must know, gram atom is the other name for moles. Don't get confused when you see gram atom in the middle. Gram molecule is the other name given for mole, because whenever we talk about gram, it has to be 1 mole. That's where the concept comes from. Okay, so be clear with these terminologies. So with all of this discussed, we are ready to any question which comes from moles, molecules, atoms, this mass and everything. So it's time that we start solving questions. So without any further ado, let's begin with some problems. Okay, so let's begin. So this is the first question we have. Let us solve it. So the question says the present atomic weight determination is based on which atom? Can you guess it? Of course, answer is carbon 12 because we everywhere we have studied AMU, mole concept. The basis was carbon. So the answer is good choice B. Next question. Henry, there's a guy. He thinks that one mole contains these many molecules. Henry, hence the molar mass of nitrogen is what? What is the answer? So take a moment, take a minute time. Please solve it. Pause the video, do it. Okay, so let's solve it now. I hope you have done it. Let's try to see how it can be done. So what is molar mass? Molar mass is nothing but it is the mass of 1 mole of a substance, right? 1 mole of a substance. That's the definition of molar mass, right? Now, how many molecules are given? These many. So we know one nitrogen molecule has a weight of 28 U, right? Then what is the mass of 1 mole of nitrogen? So 1 mole of nitrogen will have a weight of 28 U into the Avogadro number, right? Which now is this big number. So it will be 28. What is U? We know 1U is nothing but 1.667 to 10 to the power minus 24 grams. So it will be 1.667 into 10 to the power minus 24 into 6.022 into 10 to the power 23. If you do it, I saw it's plus. Minus 4, 20 is also 24, right? Yeah. So this will be, this into this is 10. And this into this is cancelled anyway. So the answer is 280 grams. So the answer is option, excellent, C. So C is the right answer. So we already discussed the solution. The answer is C. Okay. Now let's go to next question. So next question. Yes, this is the question. What exactly is gram atom? So if you remember, just a few minutes back, I told you what gram atom means. Gram atom means 1 mole. So what do you mean by 1 mole oxygen atom? Let's see what is the question saying. Yeah. What does it mean? See, 1 gram means 1 mole. 1 mole of oxygen means how many? What is the mass? That will be 16 grams. 16 grams. The answer is B. Excellent. See, that's atomic weight, which is 16 grams. 1 mole of oxygen atom means what? 16 U is the mass of one oxygen atom. 16 grams is the mass of one U. One mole of it. Next question. 1 gram molecule. What is at least gram molecule? If you remember, I just told you. 1 gram molecule is nothing but 1 mole. So here they are trying to mean oxygen gas. They should have mentioned in the question, of course. So 1 gram molecule of oxygen gas is 32 grams because 32 grams is the molar mass of oxygen. The answer is option B. Next question. So please pause the video and do it. Okay. So I hope you have done it. What's the answer of this question? See, what is the molar volume of STP of any gas at STP? Great question. The answer is absolutely P is the right answer. Good choice. Next one. What is the mass of 1 mole of hydrogen atom? Hydrogen atom, they've specified. So what's the weight of one hydrogen atom? One hydrogen atom is 1U. So 1 mole of that will be nothing but what? 1 grams. So the answer is 1 grams. Finished. So 1 gram. Then what is at least the mass of its mass? 1 gram. Okay. Then yeah, that means the answer is just 1. Just because all of the above is there, it doesn't mean all of the above will be the answer. Answer is 1A. Okay, good. Next question. What is the molar mass of dihydrogen? That you can guess, right? If hydrogen is 1, hydrogen will be, of course, 2. Option is B. Good. Next question. 1 mole of chlorine atom has how many? What's the mass? One atom. So what is the answer? C. 1 mole of anything, like 1 mole of SOx is 6.022 into 10 to the power 23 SOx. So 1 mole of chlorine atom will be 6.022 into 10 to the power 23 atoms of chlorine. Is this correct? Yes. Option B. What is the mass of 1 mole atom of chlorine? One atom has a mass of 35.5 U. What 1 mole of it has a mass of 35.5 grams. The answer is option A and B both are correct, which is option C, both A and B. Good. Next question. This is something that you can tell. Answer is again C. Same logic. 1m is equals to, of course, option number D. It's a fact-based question, so D is the right answer. Next question. Okay, this is a good one, at least on the basis of what we learned. Volume occupied by 4.4 grams of CO2. How to find that? See, first find the number of moles. How to find moles when mass is given? You can pause the video and do it, then again come back and watch it. So number of moles N is given mass by molar mass. What is the given mass? 4.4 grams. What is the molar mass? 44 grams. What is the moles? 0.1 moles. Done. Finished. 0.1 mole. Finished. Now, one mole of CO2, right, at STP has a weight of 22.4 liters, right? Then 0.1 mole will have what weight? 2.24 liters. So answer is option, yes, you guessed it right, B. So B is the right choice. See, simple. That's how we do it. Next, what is the charge present on 1 mole of electrons? Let's see. What's the charge of, now pause the video. Let's do it. What's the charge of 1 electron? That is 1.6 into 10 to the power minus 19 coulombs. So what do you mean by 1 mole? 1 mole of electron means how many electrons? 6.022 into 10 to the power 23 electrons. So if one electron has a charge of 1.6 into the minus 19, then charge of 1 mole of electron will be absolutely right. It will be 6.022 into 10 to the power 23 into 1.6 into 10 to the power minus 19 coulomb, which will give you 96500 coulomb, also popularly called as 1 Faraday. So Faraday did this calculation. So this is correct, this is correct. That means the answer is C, both 1 and 2. See, a simple question. Next, what's the weight of 0.1 mole of Na2CO3? How to find mass when moles is given? Come on, pause the video and do it. So mass is nothing but number of moles into molar mass. What is the number of moles? 0.1. What is the molar mass? That will be 46 grams plus 12 grams plus 48 grams. 106 grams. So the answer is 10.6 grams. That is option. Excellent, guys. B. Okay, next question. Conceptual one actually. So they are saying if the molar mass of substance is 20 grams, what's the molecular mass of a substance? See, molar mass is 20 grams. So its molecular mass will be very good. 20U, simple. How we can get that? Divide 20 grams by Na. Right? If 1 mole means Na molecules has a mass of 20 grams, right? Then 1 will have what mass? 20 by Na. What is 20 by Na? 20 by Na will be 20 into 1.66 into 10 to the power minus 24 grams, which is nothing but 20U. You can check. The answer is absolutely right. B is the right answer. Now, moving on to the next question. Yeah. So let's look at the next question. This question says, which one of the following has the highest mass? How to find mass? You can pause the video and do it. Mass is nothing but number of moles into molar mass. So look at the first option, 50 grams. Second option is 5 moles of nitrogen. So how to find mass? See, moles into molar mass. What's the molar mass of nitrogen? 28, right? Now 5 into 28, how much is the value? Yes, 140 grams. Next, 1 gram atom. Gram atom means 1 mole. So what's the mass of 1 mole of silver? It's 108 grams. Next, what is the mass of these many atoms of carbon? So how to find number of atoms? Number of moles given number of particles by Avogadro number. See, so roughly this will come out to be 5 by 6 moles into 12 because that's the mass. So mass will be number of moles into molar mass. So around about 10 grams. Which one is the highest mass? Yes, option B. So the right answer is option B. Now, let this be the last question we will do because we've done a lot of questions already. If you want more of such questions, you can put comment down below. I'll make more question videos on this. So let this be the last question we'll do. So see, please pause the video and do it on your own. Okay, so let's discuss it. See, how would you know the formula of number of atoms is nothing but how to find number of atoms? N into atomicity into Na. Now, 4.25 grams. So what's the number of moles? Given mass by molar mass. Ammonia molar mass is 17 grams. So 17 grams. What's the value? The value will be 1/4. So 1/4 moles. Now how to find number of atoms? Number of moles into atomicity. In ammonia, how many atoms are there? 3 plus 1, 4. Into 4 into Na. So what is the answer? Na. What is the meaning of Na? When Na is 0.6.02 into 10 by 23, which is option number, very good, A. So the answer is A. This is how we can approach this question. So I hope it is clear. So with this, we'll wind up for this video. So I hope you've understood all the questions we've done. Please practice similar question. I'll be attaching for a reference. I'll be attaching this press PPT in this description of the video. You can download and practice more such questions because there are a few more questions in this sheet which you can practice. I hope this was a helpful session. Thank you so much. And for more such contents, please subscribe my channel and like the video.